All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Good. So our objective, our warm-up number 68 is on the screen, and it reads, number 1, rewrite each expression. Part A is 3 to the negative 4 exponent. B is 1/4 to the negative 3rd exponent. And C is 3 times the square root of 3. Number 2 reads, if x to the 3rd times x to the 5th equals x to the 3 plus 5, which is x to the 8th, then rewrite 2 to the exponent of x minus 3. Number 3, it says rewrite. Part A is 4 to the 1/2 exponent, B to the 49, B is 49 to the 1/2 exponent, and C is 8 to the 2/3 exponent. And number 4 reads, graph f of x equals 2 to the x exponent, then transform using g of x equals 2 to the x plus 3 exponent, and then plus 4 as our constant. And somehow there's a little typo in here in the parentheses when we erased it. There it is. All right. So I'll give you some time for that. We don't have a lot of time. I'm going to give you a couple more minutes and we'll get started. Copy and go. All right, here we go. So number 1, it says rewrite each expression. So since we can't have a negative exponent, so 3 to the negative 4 exponent is written as 1 over 3 to the positive 4. However, if we simplify that, 1 on the numerator, 3 to the 4th means 3 times 3 times 3 times 3, which is 81. Let's go to part B, 1/4 to the negative 3rd to the negative 3 exponent. So for that one, we do the reciprocal of 1 over 4, which is 4 over 1. Distribute the exponent as a positive, so that's 4 to the 3rd, 1 to the 3rd. And if we simplify that, 4 to the 3rd is 64. That's 4 times 4 times 4. Over 1, which is 64. Part C, it says 3 times square root of 3. So on these, to rewrite these, the 3 that is our factor outside was inside of the square root. So a number to come out of a square root, we do the square root, but in order to go back in, we need to do the opposite, which is a square. So I'm going to take 3 to the 2nd power, and that's going to bring it inside. So to rewrite this, I write square root of 3 times, what is 3 squared? That is 9. To simplify inside, that's 3 times 9, that's 27. That's how we rewrite that. Number 2, to rewrite 2 to the exponent of x minus 3 is 2 to the x times 2 to the negative 3. Now 2 to the x stays in the numerator, but 2 to the negative 3 cannot be a negative, so it goes to the denominator as 2 to the 3rd power. So 2 to the x over 2 to the 3rd is 2 times 2 times 2, which is 8. All right. Number 3. Number 3 is an oldie but goodie. This is from Algebra 1. Let's see if you remember. If you notice, on all these 3, they're all exponents that have fractions. All of them have a numerator of 1, except for the last one. So I'm going to first focus on the first 2 that have a numerator of 1. Whenever you have an exponent that's a fraction, numerator of 1, that tells us that this is a radical or a root, a square root. Like this one is a square root because of the 2 as a denominator. But we call them radical because some are not going to have a denominator of 2, such as part C. So let's look at this one. 4 to the 1/2 becomes radical 4, or square root of 4. The 2 is an invisible number that goes outside, known as the index. And what does that work for? Well, that tells us how many times to multiply a number to give us the radicand of the number inside. What number times itself 2 times gives us 4, that is 2. Let's look at this one. Same thing. The exponent is 1/2. So the numerator is 1, so that's an easy one. So it's a radical 49. Now, the index, the denominator is a 2. I would write it outside, but if you guys notice, ever since you guys started with square roots, you never wrote the little 2, so we won't write it because we already know that a number times itself to give us 49 is 7. But here's the dilemma. 8 to the 2/3 does not have a 1 in the numerator, but we can rewrite 2/3. Let me write the fraction up here. 2/3 can be rewritten as 1/3 times 2. Do you agree with that? Yeah, because the 2, if we put it over 1, that's 2 times 1 is 1, 3 times 1 is 3, and it should give us that. So this is that. So I'm going to rewrite this one. Check this out. I'm going to write 8 to the what? To the 1/3 power. And outside, I'm going to write the other exponent, which is a 2. So with that said, looking at this, since this is a fraction exponent of 1/3, I know it's a radical, so I'm going to do a radical. 8 goes inside. What's the denominator? It's a 3. And outside goes the 2. All right, so let's simplify this. Let's see. What does this say? Cube root of 8. What does that mean? What number times itself 3 times gives us 8? That number is 2. But then outside we have an exponent of 2. So what is 2 to the 2nd power? 4. Now this is a skill that you should have, it should be coming back from Algebra 1. I'm going to keep using these because we're going to need those for the next concept that's coming up next week, which is logs. So stay focused. All right, let's go to graphing. So to graph this parent function, I'm only going to use 3 values on my table. X, g of x, just to make it expeditious. 0, 1, and 2. I'm only going to use these 3 values. So if I substitute 0 here for the exponent, that's 2 to the 0. Any number to the 0 is 1. 2 to the 1. 2 to the 1 is 2. 2 to the 2nd power is 4. So let me graph that. That's a little crooked. I think that's it. All right. So I'm going to make my tallies here. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So my parent function, I'm going to start from 0, 1, 0, 1, 1, 2, and 2, 2, 3, 4. Which is right there. Now this parent function was transformed by this, and we see that we have base 2 x to the positive 3, x plus 3 as an exponent, and then at the end a constant of 4. So before I continue, first of all, this one didn't have a constant, so our asymptote was at 0. There it is. This one, our asymptote, which is a positive 4, is at 1, 2, 3, 4, is at 4. However, according to the transformations, the new function, I'm going to move 3 steps to the left and 4 steps up. 3 to the left, 4 steps up. So I'm going to take this point right here, which is at 0, 1. I'm going to move it 3 to the left, 1, 2, 3, and 4 steps up. 1, 2, 3, 4. This next one, 1, 2, I'm going to go 3 to the left, 1, 2, 3, 4 steps up, 1, 2, 3, 4. And this last one, point, what was it, 3, 4? Yeah, and that, I'm sorry, 0, no, 2, 4. 2, 4, once again, 3 to the left, 1, 2, 3, and 4 steps up, 1, 2, 3, 4. So my new function is up here. All right. All right, let's move on. So heads up, guys, today's session is a little rigorous. So stay focused, make sure you stay on top of your notes because today's gonna go a little bit faster. Like I said, because they cut us our time for the lesson, okay? Here we go. Our agenda for today is warm-up number 68. We're still on exponential functions. And your home play for tonight is pages 662 and 663. Now, I included those in your Canvas. If you go to Canvas in the afternoon or later on when you're getting started with your home play, go to Canvas to the module of exponential functions, and I included those PDFs in there. Asynchronous code. P9MVY. 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 All right. All right. So your previous home play, or the last home play that I gave you guys was page 661. You should have turned that in already. And tonight's is 662. It's just 663. All right, let's get started. Our objective for today, I can graph and write exponential functions. I can graph and write exponential functions. Now, so far, with exponential functions, we've been graphing. It's been a couple of sessions already that we've been graphing only. However, let me bring back the pattern that we use for all functions. We first start with the graphing, then we apply that with the graphing and using also domain and range. And then from there, we go to writing the function from a graph. So today's going to be that day for exponentials. Today, we're going to write a function given a graph. Okay, that's why I need you guys to stay focused. All right, so here we go. Actually, before we get started, I'm going to give you a couple minutes. I want you to do get a Cornell note, get your Frere model going, and you're going to need two coordinate planes from -8 to 8 on both domain and range. So I'll give you a couple minutes, and I'll come right back so we can get started. Do that, please. All right, so let's get started. Exponential functions. In your Frere model, you should write a definition, one example, one unexample, and a hashtag. I'll have you do that on your own, and that's going to be turned in asynchronously. Let's move on. So after that, I remember we revisit our general transformation rule that we've been using throughout the year, and I've been hammering these on the warm-ups. So what are the 4 parameters that we've been working with in transformations? A, B, H, and K. So far so good, yes. From there I said, we're gonna apply this general rule, but now to an exponential function. I gave you guys the following general rule, which was g of x equals a times parentheses, b for base, and then as an exponent, x minus h for parentheses plus k. And I specifically said that k plays a second role for this kind of graph, which was our what? Our asymptote, horizontal asymptote. From there, we went straight to graphing, and I gave you guys a parent function of f of x equals base 2 to the x exponent with 2 more transformations. And it looked like this. And we agreed that the parent function was the one in black right here, and then the red one moved 1 step to the right, and the blue one moved 1 step to the right and 5 down. Now, the first 2 did not have a constant. That's why the horizontal asymptote was y equals 0. However, the last transformation did have a constant of -5. That's why our y or horizontal asymptote is -5. There it was. From there, I left you guys to do the next function by yourself. G of x equals 1/3 of x. And I went ahead and did that with you guys. And we found out that that one, if we read it from left to right, it descended or decreased or it went down. So what did we find out? Well, we found out that after we did observations with our tables and came back and did an observation for the graphs, that B is our base, and it plays 2 roles. That if it's a whole number, it's a growth function and it's increasing from left to right. Or if it's a fraction or decimal, then it's decreasing or going down, and it's known as a decay function. And just a reminder, K plays a second role. Once again, what is that second role? Our horizontal asymptote. I'm just reminding you, trying to make sure that you're keeping up with that, okay? And you should have these notes already, okay? I'm just recapping, okay? So I want to revisit the graphs that we created when we got started, these. So if you notice from here, we started with a parent function, and then we ended up with last transformation, which is down here. So we're going to use this one to write our function. So before I show you the process, let me get your noodle ready. So write your utensil down, look up to the screen. So if I was to go back in time and I said, we're going to start with functions, guys, and every function that we're going to work with usually starts from 0, 0. And I said, from now on, just to, to give it a name, we're going to call it the vertex, the vertex. And most functions that we worked with went through the vertex, whether it was a straight line, a parabola, a cubic function, a quartic function, a circle, whatever the case, okay? And the vertex is known as H and K. So that means this point, 0, 0, is also known as what? H and K. So if I was to give you the function of a quadratic, such as that, and then I gave you the transformation of x minus 3 and then plus 4. Well, by looking at it, we would say that the h is 3, the k is 4. So my new vertex, instead of being at 0, 0, would be at 3 and 4, which would be somewhere up here. And this function, this parabola, would move up here. So my new vertex would be this. Everybody with me so far? Yes, Mr. Q. Okay. So just wanted to get your noodle ready. So here we go. So what we're going to do, I'm going to take this last transform function, and we're going to write our function given that blue graph. So I want you to copy this blue graph. So copy that. And in the meantime, I'm going to erase the notes from the previous graphing that we did. So there's a coordinate plane. Copy, once again, only the blue function, which is the one down here, okay? I'm gonna pause this really quick and I'll give you guys some time for copying that blue function. All right, so with that said, so writing utensils down, let me just elaborate as to where we're at here, okay? So look up to the screen. If I was to ask you for this exponential function, the parent function, the black one, what our vertex was. So usually our vertex is at what? 0, 0. But this one's not at 0, 0. Where is it at? It's at 0, 1. So my vertex for this original function, if we want to call it that, would be that point right there, which is 0, 1, okay? So after transformations, this one, we said that it went 1 step to the right, this way, and 5 steps down, 1, 2, 3, 4, 5. So my new vertex would be here. Do you agree with that? Yes? Yes, Mr. Q. So that means this is my new H and K, okay? So I'm gonna use, for my new function, I'm gonna use this point and the point right above that, which is this one. So I'm gonna make them very bold so you guys can see that I'm gonna be using these 2 points. So let's label the coordinates of those points. So this point right here is 1, comma, -4. -4.
Genesis outside.
1, -4.
Genesis
And
outside.
this one right here is 2, -3.
Genesis.
2,
Genesis.
-3. 2, -3.
Genesis.
Is this true?
So never.
Yeah. All right. So let's label those. Okay. Because we're going to need those 2 points to write our function. And we're writing the function for this one. Okay. So here goes the process. We're going to write this as our example Q and write these instructions. Write the function of the given graph. And what given graph, which is this blue one. Don't pay attention to the other ones, this blue one. Okay. All right, here goes step 1. Ready? Step 1. Stay with me, please, because it's got multi-steps. First step is to write our form. G of x equals a, parentheses, base b, exponent x minus h, close parentheses, plus k. That's step 1. Step 2. Let's write our 4 parameters on the side so like that we know what it is that we need to find. I'm going to start with green and I'm going to write a. I need a equals 2. In blue, I need b equals 2. In black, I need h equals 2. And in red, I need k equals 2. We need those 4 parameters. We need those 4 values to substitute into our function in order to write our function. Okay? So here we go. I'm going to start with the easiest values that we can think of. And the easiest that I know from looking at our graph, look up to the graph, is our asymptote. This one. What is our asymptote? Also known as what? Our asymptote is known as k. And what is that value? It's going through the value of -5. -5. I'm going to label it right underneath here so you guys can see it. -5. Okay. Next, pay attention to this one because some of you might get confused. Look up. The next one is h. Do we know what h is? Yes, we do, Mr. Q. Really? Well, look up. Our original function was up here. Our vertex was hk at 0, 1. But then we moved it and we said this is our new hk. That means this is our h. And if I was to label this one, this will be our k, but I can't label it k because we already have k, which is our asymptote. However, this is our h. So I'm going to label 1 for h. And let me label that up here. This is 1. I'm going to put right above that right here, 1. All right, let's rewrite this now with those 2 values. So it's going to look like this. G of x equals a, parentheses, base b, x minus 1, close parentheses, minus 5. So far, so good? Yes, Mr. Q. So what are we missing? We're missing the parameter a and parameter b. So look up. For parameter a, I'm going to use green. I'm going to use the second part of this vertex of our new transform function. So we said that one was h, but the other one, I'm going to use the value of -4 to find my a. So box it like this, and next to this, I'm going to write a plus k. So what does that mean? That I'm going to use an equation starting with a plus k, and all that equal to what? -4. Do we know what k is? Yes, k is -5. So all I do is bring down the a. Once I substitute the value for k and solve for a, what do I do? +5 + 5 A equals 1. That goes right here. And substitute it here so you guys can see it. There it is. Let's rewrite this one more time. You're like, man, that's a lot of rewriting, Mr. Q. I know, because we need to find all 4 parameters. So this is g of x equals 1, parentheses, base b, x minus 1, minus 5. Okay, so if you notice, the only thing we need to worry about now is to find the value of b. Okay, look up, please, really quick. Didn't we start off with 2 points? Yes. We already used one of them, the one that was close to the asymptote, which was our vertex. We used it for A to find A, okay? So I'm gonna use the second point, which is this one, 2, -3, to find B. So how do I do that, Mr. Q? Well, I take the 2, which is our X value, and the -3, which is our G of X, and substitute into our function. So G of X is -3, X is 2, and I'm going to rewrite that. Here we go. We got up -3. I got -3 equals 1, parentheses, base B. Then I got 2 minus 1, close parentheses, minus 5. Let's simplify that. -3 equals 1, parentheses, base B. What is 2 minus 1? 1, close parentheses, minus 5. Let's solve. What is B to the first exponent? Just B. What is B times 1? B. Bring down the -5 and all that equal to -3. Let's solve for B. Plus 5 plus 5, 2 equals B. Now that we have all 4 parameters, I'm going to take my general rule and write it now using all these parameters. So you go, G of X equals A, but what is A? 1, parentheses, base, what is the base? 2, X minus 1, close parentheses, minus 5. And that is our function of our graph. You're like, man, that's all the stuff. And I told you guys, it's just like multi-steps, but most of it we've been practicing already. All the little things that we've been practicing all year, now it's coming together here. So let me just recap really quick. Let's see. We're given a graph and we're focusing on 2 points. We label the points. There they are. We write our general rule. There it is. We write the 4 parameters that we need to find. There they are. The first parameter that we found was the asymptote, which is K, which is -5. There it was. And then we used the point closest to the asymptote as our vertex. So we found out that the X value was our 8. So there it is. We wrote those inside and then we rewrote it. There it is. Next, to find A, we use the second value of the vertex, of our new vertex, and just wrote A plus K on the side. We wrote an equation, A plus K equal to that value in the parentheses. And then we solve for A once we substituted for K. There it is. We substitute values. And the last part to find B, we use the second point, X and G of X, substitute the values, simplify and solve for B. And that's how we found all our parameters. And then we wrote our function. Now, what we just did, we wrote a function for growth or ascending functions. However, your home plate was on what? Descending or decay. So let's do one of those. Copy this. Example 2, and it reads, write the equation of the function given the graph. Let me zoom in so you guys can see the points that you can make there. Let's see. One thing I want to point out, notice here the scaling is by halves. Half, 1, half, 2, half, 3, half, 1, and so on and so forth. So plot those 2 points, plot your asymptote. And So whenever you get to these guys, usually on descending or decay exponential functions, they're usually going to give you by fractions. So work with fractions throughout, because usually who remembers that the base is always a fraction, right? Or a decimal. But let's work with fractions throughout. So label those, please. I'll give you a minute. All right. So with that said, let's go over our process. Here we go. First things first, we label our 2 points that they give us. What are the 2 points that they give us? This one that's closest to the asymptote. And what is that point? Coordinate is 1/2 and 2.5, but I'm gonna leave it in fractions. So it's 1/2, comma, and we got 1, 2, 3, 4, 5 halves. 5 halves. That's this one. This other one over here is at -1/2, -1/2, comma, and 1, 2, 3, 4, 5, 6, 7 halves. 7 halves. All right. The very next thing we do is write our general rule. Our general rule is g of x equals a times base b, x minus h, close parentheses, plus k. And over here on the side, I'm going to write, we need what parameters? We need a, we need b, we need h, and we need k. All right, now that we have this, we need to get started with our parameters, which is the easiest one. Oh, Mr. Q, the easiest one is k, because that's our asymptote. So the dotted line, label it k, which is what value? 2. 2, and I'll write it in here, 2. Next, we need an h. So by looking at it, our closest point to the asymptote is this one. So that means this is our h. Oh, sorry. This is our h, which is what? 1/2. 1/2 right there on h. So let's rewrite this. Here it goes. G of x equals a, parentheses, base b, x minus 1/2 plus 2. All right. Next, we need to find a. How do we find a? Oh, well, we use a second value, Mr. Q, of that transformed vertex, and I write a plus k. So I'm going to write an equation over here, a plus k equals to 5 halves. But what do we know k is? K is 2. So a plus 2 equals 5 halves. But since we have halves, we need to work with halves, don't we? Yes, Mr. Q. So how many halves are there in 2? How many halves in 2? All right. 2 has 4 halves. So I'm going to subtract 2 from each side, which means I subtract 4 halves. Subtract 4 halves from each side. So we're left with a equals 5 halves minus 4 halves is 1/2. So that goes right here. And that goes right there. So let's rewrite this. Now with that a, g of x equals 1/2 times base b, x minus 1/2, close parentheses, plus 2. All right, what's left, guys? We need to find b. And how do we do that? Well, we take the second point over here, and this is going to be our x, and this is going to be our g of x. So g of x is 7/2 equals 1/2 times b x. Oh, sorry, I'm going to replace the x with what? -1/2. -1/2 minus 1/2 plus 2. All right, let me zoom in. Let me do that work right there. Here we go. So 7/2 equals 1/2 parentheses b. What is -1/2 and -1/2? That's -1 plus 2. Let's continue. 7/2 equals 1/2. Can we leave this as with a negative exponent? No, we do the, goes to the denominator. There it is, plus 2. Continue. 7/2 equals, what is 1 times 1? 1. 2 times b is 2b, and then plus 2. All right, next, we need to solve for b, so I subtract 2, but this is a fraction, so what is 2 in fraction form? So we're going to subtract, what is it? 4/2 from this positive 7/2, so this is 3/2 equals 1/2b. And now that we have a proportion, let's see, 3 times 2b is 6b, and 2 times 1 is 2. So divide by 6, b equals 1/3. All right, let me zoom out. Let me write that over here. B is 1/3. All right, now that we have all values, let's write our function. We have g of x equals, what is a? A is 1/2. 1/2. Parentheses, what is the base? What is b? 1/3. And what do we have as an exponent? We have exponent x minus 1/2, close parentheses. And what is our constant? Plus 2. Woo. Now, is the process the same? Yes, Mr. Q. So basically, I gave you one that was ascending, one descending. Hopefully that clarifies today. You're going to have, I think both of the examples are for decaying functions. So from 1 to 5 so far with the processes. I know it's multi-processes. How do you feel? Got some 4 5s, 4 5s, 4 5s, 4 5s. Yeah, 4 5s, 4 5s, and a 3. All right. So I'm going to go ahead and stop right there, guys. Your home play for tonight, once again, pages 662, 663. Enjoy your home play, and I'll see you guys next time. Peace.